In this video, we're going to practice rewriting bases so that we can use the power rule for exponents. Here's an example. I need to rewrite the base, that is the 27, into exponential form, and then I'm going to simplify using the power rule for exponents. And remember, the power rule says if we have the power of a power, we can multiply the exponents. So I look at 27, and I'm going to write that in exponential form as the third power of 3. Notice I still have an exponent of a third. Then, by the power rule for exponents, I can multiply 3 times a third, and that would give me 1. Last, we don't write exponents of 1, and so this would just simplify to 3. So 27 with an exponent of a third can be replaced with the number 3. Try this one. Now my goal is to be able to use the power rule to make this simpler. And what comes to mind for me is that 81 is 9 squared. And so I'm going to think of 81 as 9 squared. And now I have power of a power. And I can multiply the exponents. 2 times a half would be 1. So we'll have 9 with an exponent of 1. And we usually don't write exponents of 1. I'd like to use this problem to make a point. There's another way that you can do this. Some of you might have thought to yourself, well, 81, if I prime factored that, would be 4 factors of 3. That is, instead of writing 81 as 9 squared, we can also write it as the 4th power of 3. But notice our answer turns out to be exactly the same. By the power rule, I would multiply 4 times a half. That would give me 2. And 3 squared will, again, give me 9. Try this one. Now we can think of 16 a couple of ways. One is 4 squared, but that's not going to necessarily help us. I'd really like to get 16 written as a base with an exponent of 4. And then when I multiply and reduce, I'll get a nice number to work with. So I'm going to think of 16 not as 4 squared, but instead as 2 to the 4th. And then when I multiply my exponents, I'll get 12 over 4, which will be 3, and I'll end with an 8. Here's another. My goal here is to write 49 in exponential form, so the exponent will be a 2. Of course, 49 is 7 squared. Now I can use the power rule, and I'll multiply to get an exponent of 6 over 2, which reduces to 3. And using a calculator, I find 7 cubed is 343. This looks a bit like one we did earlier, but it's a little different. Now again, we can think of 81 as 9 squared, but that's not going to work with 4 as well as 3 to the 4th will. And so I'm going to think of 81 as 3 to the 4th. Then when I multiply the exponents, I'll get 12 over 4, or 3. And 3 cubed is 27. See if you can get this one. I'd like to write negative 32 in an exponential form, which has an exponent of 5, because then that 5 will reduce this 5. And if I prime factor 32, I see that it's 5 factors of 2. And I'll need to get a negative when I multiply those 5 factors together. so my base should be negative 2. Now I can use the power rule. This will give me an exponent of 10 over 5, which is 2. And the quantity, negative 2 squared, is 4. And here's our last one. Be careful, this one's pretty subtle. Recall, without parentheses, the exponent of 1/3 is only affecting the 27. So I'm going to have to keep this sign outside as I rewrite 27 as 3 cubed. Now, by the power rule, when I multiply 3 1/3, I'll get an exponent of 3 divided by 3. Of course, that's going to give us a 1. And then at the end, I'll bring in this sign, that is, it's the opposite of whatever this is, or you can think of this as a factor of negative 1 times whatever you get, and that'll just give us negative 3. Well, that will conclude this video, where we've rewritten some bases so we can use the power rule for exponents.